to talk about polar curves. The general form of a polar curve is given by the equation R equals f of theta. That will be the general form. Well, there are exceptions, as we can see. Remember, we know that line equals, we can express a line as y equal f of x or y equal mx plus b, and the exception will be a vertical line where we have x equals a constant, right? Another exception, well, that will be the exception. So, and we don't have y at all in it, so we cannot express it as y equal f of x, just the relation x equal a constant. We have something similar here. We have an exception where theta equal, so we can write an exception here. An exception when we have theta equals a constant. Okay, so this is similar to the exception x equal a constant. All right, so let's jump into an example, and I'll do it on the next page. And this will be example 4. Example 4, example 5 demonstrate this. The first question is, what curve is expressed by r equals 2? Okay. The ball is in your hand. Well, what do you say? I'm sorry? So, instead of r equal f of theta, we have no theta at all. We have r equals a constant too. I gave you an exception, theta equal a constant, but I didn't say a word about r equal a constant. That is correct. A circle with radius 2. Can you explain why?
Because any value you plug in, as long as it equals, like any function you make, as long as it equals 2 will apply. So, I guess any trigonometric.
Yeah, I agree. Any point you choose on the curve is r equals 2. What about theta? Doesn't play a role. It doesn't matter. Theta can be anything. Another way to express it is to say that every point on the curve is 2 units away from the pole, regardless of angle. So the angle is not an input. So the solution is correct. This is a circle centered at the pole. Remember the pole or the origin in xy with radius equal of 2 units. Okay. And here is a column, and we're going to say that every point on the curve is 2 units away from the poles. the mathematical term or geometrical term is every point is equidistant. Equidistant. Okay, so equidistant. Really the correct term is to say this is the geometric place. I don't know if you read something like that. If this was a geometry course, I would say this is the geometric place that is 2 units equidistant from the pole. That will be the correct way to say it. All right, the next example, example 5, something I alluded to earlier, and it goes like this. Sketch the curve theta equals 1. So what is the solution here? What does it mean theta equals 1? Here, we remember this is theta equals 0, right? Radian. This is the polar axis, and this is the pole. Where is theta equals 1? It will be a straight line. But how are we going to draw it? By the way, what is theta equals 1 in degrees? What are the units of 1? Let's start with that. I'm sorry? It's in radian. Yes. In calculus, the default angle measure is radian. How many degrees is 1 radian? No, that's pi over 2. Go ahead. It's 57 and some. Okay? So what will happen is from the reference, from the polar axis, remember the polar axis is our reference, we draw an angle of 1 radian, theta equals 1, and now every point along this line has that angle, right? So, and the line can be, R can be either positive or negative, so it's a straight, ooh, I missed the points. Sorry about that, I'll make the points a little bit thicker. So every point on this line has theta equal 1 radian. The difference is points on this side, right here, this goes to infinity. This is where R is positive, and point on this side of the line are where R is negative. But we don't know what's R. R can be any value. Okay, so it's like saying X equal constant, which give us vertical line, and we don't know what's Y, and Y can carry any value. Here, R can carry any value, and theta is a constant. So instead of having vertical line, we can have line passing through the pole in any direction. Again, keep in mind that this is the line with no endpoint. This is a line with no endpoints. That's the definition of a line to begin with. All right, we are due for the next example. And the next example is example 6. And this is a longer example, so I'm going to start in the recording.